I'm Anil Kumar sharing with you some examples where absolute functions are part of your algebraic expression. And now let us see how to write the whole function as a piecewise function. In this particular video, we have two examples. The first one is f of x equals to x plus 2 divided by absolute value of x plus 2. The other one is g of x equals to 2x minus 1 divided by absolute value of 2x minus 1. They are very similar examples. I'll solve one and expect you to pause the video and answer the other one. So let's begin with the first one, which is f of x equals to x plus 2 divided by absolute value of x plus 2. Now, absolute function, absolute value of x plus 2 could be written as a piecewise function, and that is to say, it is this positive value of x plus 2 if, let me write, if x plus 2 is greater than or equal to 0. On the other hand, it is negative value of x plus 2 if x plus 2 is less than 0. Now, this inequality could be solved and we could write this as x plus 2. I'm avoiding to write if in most of the cases. I'll do that here again. X plus 2, taking 2 to the right side, it becomes minus 2. And this could be minus x plus 2 when x is less than minus 2. So that becomes the denominator of this function. Now, since denominator has been split into a piecewise function, the function itself could be written as a piecewise function, correct? So the function f of x can now be written as x plus 2 over x plus 2 if x is greater than or equal to minus 2, or it is equals to x plus 2 over negative value of x plus 2 if x is less than minus 2, correct? Now you could write this as that is 1, right, when x is greater than or equal to minus 2, and this is minus 1, correct? Minus 1 when x is less than minus 2. Perfect. So clearly you see that this function is either plus 1 or minus 1. So I could sketch this kind of here and say at minus 2, we have this step. It could be when it is greater than minus 2, greater than equal to, we are saying. But remember, it cannot be equal to, right? So I should strictly, when I have divided this here, divide this here, I should not use equal to. Is it okay? Because x is not equal to. So let me write down here, x is not equal to minus 2. Since at minus 2, the denominator is 0. Perfect. And therefore, when you sketch it, you have to sketch with a hole at minus 2. 1 means when x is to the right side of minus 2, kind of like this. And to the left side again, a hole here. This is very important, and like this. So this is, we have the value at plus and minus 1, right, for the given function. And as you can see from here, that the domain here is what? Domain is from minus infinity to 0, union 0 to infinity. Do you see that? Domain is not all real numbers. This is very important to understand. And what is the range? Range you can write as y equals to plus and minus 1, correct? So anyway, so this really helps you to understand the whole concept. And remember, denominator cannot be 0, right? And therefore, it is important to exclude that equal to mark from this particular example, okay? Now let's see how to solve the next one, which is exactly similar with slight difference. So we'll rewrite. This is a good practice question, okay? You can pause the video, practice how to write these kinds of functions. Okay, so this should be 2x minus 1, the whole thing, positive part. When 2x minus 1 is greater than or equal to 0, negative of 2x minus 1 when 2x minus 1 is less than 0. Perfect. So now we'll solve this inequality. We'll write 2x minus 1. And when I take 1 to the right side, it becomes 2x greater than or equals to 1. And on this side, it is 2x minus 1 and 2x less than 1. Go further, divide by 2. Okay. So I'm taking my time to show you all the steps here. You could straight away write this function like this, which is 2x minus 1 if x is greater than equal to half, right, dividing by 2, or negative of 2x minus 1 when x is less than half. Perfect. Once you know that, you can substitute this right there. Now remember one more thing, that is, in the denominator we cannot have 0. So it's good idea to write a restriction here that x is not equal to half. Now I'm putting that in red to be very clear. This is important. If you miss it, you get a wrong answer actually. Perfect. Let's now write our function, which is g of x. So g of x is equal to, we'll replace this as a piecewise function. So I could write g of x also as a piecewise function. Is it okay? So g of x is equal to 2x minus 1. Let me write 2x minus 1 divided by 2x minus 1 when x is, I'm writing greater than, not equal to, since it cannot be equal to half. This expression g of x, right? So greater than half. Is it okay? So this is a very, very important step. And on the other hand, it is 2x minus 1 divided by negative of 2x minus 1 when x is less than half. So you should not have equal to sign this. Perfect. Now that clearly indicates this is 1, right? So the function g of x is actually equal to plus 1 depending on the value of x, if it is greater than half or it is less than half. Do you see that? So that is how the function will be, and you can always sketch it. Let me sketch it right there. Okay, so it is plus and minus 1 when x is greater than half or less than half, right? So at half, the function could be going this way as plus 1, and it could be minus half like this. But remember, there will be a whole for both to start with, and this point is at half. That is how you're going to sketch it. So in the domain is all real numbers, right, except for half. Range is plus and minus 1, right? So what we notice here in both the examples is, now here the domain is, you could write this as equals to x belongs to real numbers where x is not equal to minus 2, and the range is equals to, you can say y equals to plus and minus 1. Is it okay? Similarly here we can write domain as let me use different notation for domain this time, minus infinity to half, or union half to infinity. Okay, and as far as the range is concerned, let me write here y equals to plus minus 1. So for such functions, the range, you will notice, is plus minus 1. Domain will have one discontinuity, a hole, at the point which makes the denominator 0. So it is a hole at this point, since we have a common factor in numerator and denominator which cancels out. So that's a very important point to remember, and I hope this helps to understand the very basic concept of involving absolute functions in algebraic expressions. I'm Anil Kumar. You can always put some likes, share your comments, and feel free to post questions. Thank you, and all the best.